Section 1.3, number 76. We're asked to model the data from a business. So I've reproduced the chart, and I've also given the plot. And it says that the functions that we're going to be using are this piecewise defined thing with negative 1.97x plus 26.3, and the quadratic 0.505x squared minus 1.47x plus 6.3. Okay, I've plotted this as well as shown the pieces here. In A, it says, identify the independent and dependent variables and explain what they represent in the context of the problem. So our independent variable is our x. Time goes forward independent of what we do. Right? So our independent is x, and this represents time. Our dependent is the y, and this represents the profit. Okay, or revenue, I suppose I should say. Okay, it's the money that's taken in for this business. In B, it says that we have used, I've given you these equations, but we haven't said what the domain is. Now, the quadratic part, the linear part, the 1.97x plus the 26.3, well, that's the linear piece right here. And that looks like it's good from about 7 until about 12. So I'm going to do x greater than 6, since it's going to be the piece that goes along with there. The quadratic piece, this thing, well, that's this. And it looks like it's pretty good from 1 to 6. So I'm going to say that this is good for x between 1 and 6. And it certainly captures this data point much better than the other one. So I want to have that to be the equals to 6 bit. And the linear piece is going to be greater than 6. Okay, since that seems to capture everything 7 and above. All right, so that's part B. And it says C, use the mathematical model to find f of 5. Okay, now f of 5, I'm running out of room, so we'll move on to the next slide. Okay, so now using the model to calculate f of 5. 5 is certainly less than 6, so we're going to use the quadratic piece, since that's the piece that fits the data around 5. So we're going to use the piece 0.505x squared minus 1.47x plus our 6.3. Okay, so the model says 0.505 times 5 squared minus 1.47 times 5 plus 6.3. Now I'm going to put that into the calculator and write the number down. That's going to be the easiest. And out of my Google calculator, it says out of the model that f of 5 is 11.575, and if we look at what's happening on the data says it should be about 11.5, and I think that's a pretty good model, right? We're within a couple percent of the actual answer. So what this means is that the model predicts that we'll have a revenue of 11.575. The actual data we have on that is 11.575. Okay. Now, next one says that D, find f of 11. F of 11, right? Well, 11 is greater than 6, so we want to use the linear piece. So the linear piece says that it's negative 1.97x plus 26.3. So instead of the x, we want to use 11 there. Right? So this is going to be negative 1.97 times 11 plus 26.3. Plugging that into our calculator, we're going to get that this comes out to be 4.63 according to this model. So that's going to be the revenue that is approximated by this model in the 11th month. It's 4.5, that's awfully close, so our model is a little high, so it kind of over predicts the revenue in the 11th month. Okay. So how do they compare with the actual values? They're pretty close, 10%, 5% or so. For a mathematical model of a real-world situation, that's pretty good, particularly economic one. So I think that's I think it's a pretty reasonable model in this case. That's part E. Okay.